let's get started with this webinar. This webinar itself is being recorded and will be sent to you folks in about 2 days, probably, so you can watch the recording again. And again, warm welcome from our side. Our side meaning my name is Alain Pasek. I'm a senior solution engineer with HashiCorp. And we'll guide you through this webinar with a hands-on lab at the end. And Jan is in chat, where you can ask questions during the Q&A or using the Q&A button, and you can ask whatever questions you might have when it comes to ACME and Vault. But we will start off right now. All right. So a little bit of an agenda before we get into it. First, we do a little bit of a recap. Why do we actually need certificates, right? Just to have the common background of it. Then what is the problem with the classical certificate authorities that we currently have or that are on the market since the 90s, the 80s, whatever, right? And then we introduce ACME and Vault eventually, and then have a hands-on lab where we configure the whole thing. All right, let's get going. Let's do not lose any time with the first agenda point, which is why do we need certificates again, right? So why do we care about certificates is really something that might be not widely known, but hopefully widely known. So first of all, HTTPS, right, is the de facto standard basically when it comes to web traffic, right, and encryption of such. It is the minimum level of security that you guys need in order to have a functioning website, right? If you log into Chrome and you open a HTTP website, right, you will get the warning, stuff like that, right? So this is eventually why you need certificates. Why? Because the protocol that is being used is TLS, also known as SSL, which is the old implementation as such, right? Which provides this level of data privacy, respectively, data integrity, right? And which uses symmetric encryption, which relies eventually on certificates, right? So in order to establish HTTPS, TLS connections, right, we need certificates, and we need certificate authorities that can create those certificates, respectively, issue those certificates. So this is the first why do we actually need certificates again, and why are we talking about ACME? So we have already usually a CA within the environment of a lot of customers, right? They have their own classic / legacy or existing CA, but what's really the problem with it? And here I want to go and dig a little bit deeper into the classical ones. So the classical ones are more or less a set of ad hoc procedures that you need to do, right, in order to go ahead and issue a certificate, right? It is really natural language based, right? So it's a lot of manual steps eventually, and managing those certificates from a lifecycle point of view as well becomes a huge burden, right? You do not need to only issue the certificate, but eventually you need to rotate them, right? And what we've seen out there is usually the process is so problematic that users will mostly go ahead and issue a wildcard certificate, 2 years, there you go, right? It is not really something that is something that people like, you know? So especially the rotation process is a pain as well. And maybe the last piece on this slide will show you something, right? It says like, we do have a solution, but well, it's just not automated or easy or well adopted, right? So this has been an issue for quite some time. And just going through maybe some user experience, right? So what is the typical user experience coming from the RFC 8555, which is more or less the RFC for ACME. So what we can see here is first what you need to do, or a user need to do, right, is generate a CSR, right? The user cuts and pastes it into a web page, right? And then you need to do one of the following methods in order to prove the ownership of a domain, right? So usually certificates are domain validation ones that you need for the whole thing, but you need to validate that you have ownership of this domain. So for example, you need to provide a challenge in a specific place of a web server. Maybe you need a DNS record, right? Or maybe you have a challenge that hopefully the email address will respond accordingly. And then you are able to eventually go ahead and issue a certificate. So something that the folks of ACME found out is that this is typically, just to obtain and install a certificate, takes up to 1 to 3 hours just to obtain and install the certificate, meaning you haven't rotated it yet, right? You haven't done anything but just getting the certificate. So what we found out, what is rather interesting, is a typical certificate request is rather a little bit longer than even the 1 to 3 hours, but rather 1 to 10 days, right? So the support request, or you have a CSR created, right? Then you open some sort of support request, then you get a certificate, then you configure your service, and then eventually you start all over again, right? So this is a long-running process, a process that you do not really want to go through ever again. And the result is long-running certificates, wildcard certificates, right? So you have a lot of things that you actually don't want eventually. So how can we solve this, right? And one of the ideas on how to solve this is actually ACME, right? So what is ACME? ACME itself, right, is a way to automate the process of the verification as well as the issues or the issuance of certificates, right? As well as certificate revocation. It is built respectively, has been initially developed by Let's Encrypt, right? So Let's Encrypt itself uses this standard in order to issue certificates. It is more or less, right, over 1 billion certificates has been issued using this particular method, which allows it to scale massively, right? And this is something, especially in enterprise environments, that you want, right? You want to scale. So it is scalable, plus it is a well-trusted and eventually widely adopted standard, which is the RFC 8555, if you want to track it yourself, right, and go ahead and into the nitty-gritty stuff of it. And it simplified basically the deployment and the management of those certificates. So this seems all cool, right? But usually what we see is there's a new thing going on, right? But it's actually an ecosystem that supports the whole idea of it, right? And the good thing is, yes, right? So it is not only that this new type of method for managing of certificates is cool as a protocol, let me put it like that, but it is also widely adopted, right? So what you have here is just like a bunch of all-time favorites, I'd say, when it comes to web servers and certificate managers who can work with this standard. And it is Apache right here, right? You have Nginx, where you can configure it, Caddy, which we will use today in the hands-on demo. Even IIS, from Microsoft point of view, can work with it using a tool called WinACME, right? Then the most important one is something like CertBot, which is also available, usually used in Kubernetes, for example, but also Kubernetes Cert Manager has the option to work with ACME as such. So why is it becoming the new standard, so to say, right? So ACME itself is an open standard first and foremost, right? It has been developed, has been issued by using this standard, over a billion certificates has been issued, right? So massively adopted, so to say. We have a lot of community support when it comes to this. It reduces the costs as well for organizations when it comes to this management overhead that you have with classical VMs, with classical CAs, right? And you can support also those backup CAs in the back end, right? So we'll go through that in just a little bit, but it is becoming more or less the new standard for issuing certificates, just because it just takes minutes rather than hours or days to issue a certificate. So why are we talking about ACME, and why don't we talk about Vault yet? Bear your horses, it will come just now. So with Vault 1.14, what we have done is we have enabled support for the ACME protocol within Vault, right? So we have extended our PKI secret engine, which we'll talk about in just a minute, what that means. And what we can do is Vault can serve now as an ACME server for validation, for the issuance of it, for the rotation, and for the revocation. So the complete life cycle management of certificate management can be handled by Vault now, right? So this is why we're talking about it. Before we dive into how it works together, we need to first go ahead and see what is the Vault PKI again, right? So maybe some of you have heard about it before, maybe some of you haven't. So let's talk about Vault and the Vault secret engine, the Vault PKI secret engine more particularly. So this engine itself, right, generates those certificates, right? And it does so without going through any manual hurdles, so to say, right? So Vault itself is already able to go ahead and create those certificates using Vault methods, right? Keeping the TTL relatively low, right? We can automate all of this using Vault native methods, right? Or measures, and then we can go ahead and scale this approach towards the idea. And the idea is to have unique certificates, right? And the pain of the revocation and the rollover is relatively over, because we can use these Vault methods in order to go ahead and create those certificates in a automated fashion and in a timely manner, right? So how does it look in detail? Here you see a picture which is quite interesting, I'd say. It's quite loaded as well, but this shows you the art of the possible, so to say, right? What is possible with Vault and just the PKI secret engine, right? So I will just go a little bit into nitty-gritty stuff of it, and then we'll keep continuing, and I won't go through all of it. But what we have here is, for example, Vault sits in the middle right here, right? We can introduce Vault with Jenkins for delivering certificates. We can introduce it with ServiceNow. We can work with a Cert Manager, Key Factor of an AV, which we'll come to in just a little bit, right? We can integrate other certificate authorities as well and build a trust relationship, right? So maybe my root CA shouldn't be Vault, or I don't want it to be Vault, then there you go, you know, you just configure it, and you can do so if you wanted to. So skipping just over this slide, right, you have also ecosystem and integration possibilities. Two things here, right? One key factor that is widely used within organizations, as well as FNI, that can be introduced also or work together with Vault in order to go ahead with this. So let's go ahead, just explain how the basic PKI workflow works, because we will eventually configure the Vault PKI, and then on top of it, we will enable ACME as a protocol on, that relies though on the Vault PKI. So usually, they very basic workflow, right? Is you have your users right here, they authenticate towards the Vault and then perform some sort of operation, right? So this is the basic workflow itself. If we go one more, what we have then is you have a token with some sort of policy, and then you request a certificate, right? Where it checks you whether you have the right domain, no store, right? What's the TTL of this domain, not domain, but rather certificate that you are using, right? And then you can combine it even more and say, all right, maybe I have a root CA right here. I have an intermediate CA right here. Here's my application and here's my role. And here's a little bit, how does it work, right? The signing of the intermediate CA happens via the root CA, right? The intermediate CA creates the certificate for an application. The application itself, though, before it is being issued, requests it over a role. This role eventually creates the CSR, right? And the certificate is being done. So how does it look like in action? Just like in 1, 2, 3, 4, right? So first, some sort of platform ID is authenticated to Vault. Then you have an authorization that takes place, for example, right here, right? Then the client itself posts the cert requests. Then you get it returned, and then you can use all your tools that you are using before, right, to validate, deliver the certificate, and so on and so forth. So this is just the basics of how does the PKI secret engine work without ACME, right? And you have, as I mentioned it before, also the opportunity now to not only go ahead and say, all right, my root CA should be Vault-based, but you can also say, right, my root CA is not in Vault, right? My root CA is a Windows CA. My root CA is some Linux implementation of a CA, right? And we can integrate it with 2 intermediates if we wanted to. We can do 1 intermediate, doesn't really matter, right? So we can do it as how we want to do it, right? We can say, for example, maybe we have a root CA here, and then we have an intermediate CA that is also not involved, but the issuing CA, which are issuing eventually the certificates, is involved, right? That can eventually create then the certificate. All right. So how does Vault, the ACME workflow look like? And first, I want to give you a high level, and then we go into a little bit of a sequence diagram on how does it work. So from a fundamentals point of view, this automates, or ACME itself automates all the actions that we have done manually using this 1 to 3 hour or days even process, right? This process is being automated using the Vault, using the ACME server and the ACME client, right? ACME clients we've seen before. There can be quite a bit, and we'll look into it in just a bit. The communication happens using JSON web signatures, right, over HTTPS. This is how the communication happens between a client and a server. Then it is primarily used to get those domain validated certificates. And the authorization happens while with a challenge, right, that I've mentioned before. Also, the classical CA have a challenge, but this is an automated challenge, right? And it generates a token, and this is being signed. What does that mean if we go, whoops, how does it work in detail? And then we go into the sequence diagram. So you have first the request itself, then you have the client, right, who is initiating this certificate request. Then you have the ACME server who responds to the requirements request. You create an account, you validate your domain, and eventually you get the certificate. How does it look in detail from a sequence point of view? And here, I know it's a little bit loaded, but just to give you the right things here, how does it look like? The first thing that happens is I want to see what is the directory of ACME, right? This is the first call that is being put from the client, which can be, as mentioned before, caddy, IS, whatever, right? Certbot. Then the ACME server provides you with the directory. You generate a key pair with a public and private key. You get a new nonce for the purpose of registering an account. Then you sign the registry with a private key. you register an account using JWS, right? Includes the nonce and the signature being the private key and encrypted method, right? Then you have the registration confirmation, and then you create a new order that we will see also in detail once we go into the hands-on lab, right? Then once the order is done, we sign the order with our private key and now say, I want to have a new certificate, and we are presented with a challenge, including a token, right? So we need to now respond to that challenge, or the client does, and eventually sign everything, right? And we will get back the result of that challenge, right? And finally, we finalize, so to say, the order with the CRS and the JWS. Certificate is ready. We download the certificate, request to download it, and we can download it. This is more or less how it works from a sequence point of view, right? How does ACME work? All of this process is totally automated, right? But just to give you the sequence between ACME client and so on and so forth, I couldn't find anything that explains it properly. So this is maybe something that helps you quite a bit. All right. So Vault as an ACME server, how does that look like? As I mentioned before, this is now a similar slide to the first one. Once we have Vault 1.14, we can go ahead and create Vault with ACME itself. We have the ACME ecosystem right here, right? Caddy, Circuit, Apache, ISS, however you want it, right? We can, if we wanted to, optionally also integrate HSM into the whole idea, right? To increase the entropy level and the encryption, right? Or connect it to one root CA or to a immediate CA, however we want to play it, right? So that is more or less the idea as a integration pattern. And here, just like a little bit simplified, how does it work, right? From a workflow point of view, generate the key pair, we issue the challenge and send the token, we respond to the challenge, we verify the authenticity of the client, right? And we eventually retrieve the secret, not the secret, but the certificate. So this is one, but now let's look at the challenges, right? So we have multiple challenges, and this is the first one that we can use, right? The first one itself is HTTP, right? Where we basically verify ownership because we write a file containing a token and footprint into a HTTP address that is being well known by ACME, right? And then we get eventually the validation of that we own this particular domain. Then we have a second one, which is the TLS challenge, right? Where we generate a self-signed certificate in response to that challenge, right? So this is something that we are doing in order to show proof of having these domain. And the third one that we have is more or less the DNS validation, where we just go ahead, create the TXT record right here, which contains then the response to the challenge and verifies that we have ownership for those things, right? So we come later towards what are the considerations, what may be best practices, what should we do, maybe when, where. Let's see how much time we have, right? But this is more or less the three challenges that we are supporting with Vault and ACME. So what is the configuration and the considerations that we might want to have a look at when we are going ahead and configure both of those things? So Vault itself, right, what we want to do first and foremost, or like what is actually only supported, is we have a maximum lifetime of 90 days. So only those certificates that we are issuing are only valid for 90 days, meaning that those certificates cannot extend 90 days if we want to use ACME. This is based upon the reason that ACME itself automates all of those nasty steps, I'd say, that we have initially in order to go ahead and automate the burden that is put upon us eventually. So therefore, we can go ahead and have this 90 days as an idea. As I mentioned before, we support 3 challenges, which is the HTTP, DNS, and TLS. The vault accounts itself, right? As I mentioned in the sequence diagram, as you can see, right? Those accounts are created in the ACME directory, which is under the mount ACME directory, right? And there we see it. And then we have vault roles that are working within those directory. So the authentication piece now, differently to vault PKI, means we are authenticating with the ACME protocol rather than using vault as a authentication method or as a method of authenticating ourselves / the client towards vault. Everything is now handled based on the standard of ACME. Whoops. So how are the ACME directories, right? So we have a couple of possibilities now on how to configure the directory. One of those things is what we will use today is we sign verbatim, right? It is not best practice to go ahead with this and go ahead with a default issuer and so on and so forth. But this is the easiest way to get started, right? But eventually what you want to introduce is maybe only certain role can issue certain certificates, only issue a reference, only certain other references, right? So you can play around a little bit on like how much you want in terms of role-based access control, I'd rather say. How do you want to go ahead and create this this piece of how you want to configure Vault in order to go ahead and create a proper certificate that works for you. So configuration part 1, we will go ahead and do it ourselves in the hands-on lab, but just that you can see it, right? So first we need to set the cluster path on the whole idea, meaning we need to say what is, where do we mount the whole thing, right? And then we tune the PKI a little bit, where we say, now tune please with these specific measures in order to allow ACME to work, right? Otherwise, if we do not tune this secret engine, then it won't work. So this is the first configuration piece that we need to do. And then we have the second one where we say, right, we've mounted now something like PKI, for example. So PKI, then we have a config ACME and we need to enable it, right? Enable true. And here we can also go ahead and configure a couple of things, right? And work on a couple of things. So allowed rules, who can actually issue it, right? From a Vault point of view, what is the default directory? And here you can see what might be certain things here. We won't go ahead and talk too much about AAB today, right? Which is not required, meaning we can introduce against man-in-the-middle attacks certain other measures, which is the external access binding, right? AAB, in order to increase our security when who can do what when, so to say. So this is just the idea of or this slide itself shows maybe a little bit more the differences between what we may know already, which is the PKI piece of Vault versus ACME that we have now as a standard, and what we will talk about today. So the authentication piece I mentioned before, right? Here we'll use the Vault authentication and workflow, while the authentication here in ACME are being handled using the challenges, plus additionally, if we have configured it, the AAB, right? The storage is also different, right? While in Vault PKI, the certificates do not need to be stored. The certificates in ACME are always stored, right? When it comes to policy templating, we can leverage it, meaning we can work with the Vault agent, for example, or other methods, right? While we can't be leveraged in ACME because, well, it's not the standard, so to say, of ACME to have support for Vault templating, obviously, because it's an RFC, right? And here we, when it comes to the lifetime, right, we do not have an explicit maximum set when it comes to the PKI. Those short TTLs are encouraged, but we can potentially go ahead and create a 2-year certificate if we wanted to, right? While in ACME, as mentioned before, we have a maximum of 90 days for the certificate to be issued. All right. That's more or less the basics of it, right? We will talk about, we'll now go more or less through the hands-on lab. I'll share the link within the chat in just a bit, and then we can go ahead and create ourselves a Vault server, go ahead and deploy a web server as well, configure the whole thing. Eventually, what we want to achieve is the following, right? I just want to show it to you before we go into it, what we will configure in the hands-on lab. So what we'll configure is Vault itself. Within the root namespace, we have 2 secret engines. One serves as the root CA, the other one serves as the intermediate CA, which is eventually ACME enabled and issues the certificate towards our ACME client, which is a Caddy web server, right? So this is the goal itself of the hands-on lab. We have a couple of bonuses here and there that you can choose to do if you wanted to, and then eventually we'll come back after that session to talk about the summary of this. All right. So let me just go ahead and share this link with you. If you have questions, feel free to use the Q&A, and hopefully everybody can go ahead and access it. Let me also log in, and then we can go ahead in just a moment. Right. So what you should see, something similar to this, right? I'll wait 1-2 minutes for everybody to click on the link to be able to go ahead in it. It is a guided lab itself, right? So you can also do it at your own pace if you wanted to, right? But I will go ahead and do it for you, with you, so to say. All right, so let's start here with the basic of it, right? So what is the first thing that we want to do? The first thing is we deploy our web server and do a curl. So first thing that we are executing here is we'll make a folder for the data of Caddy. And what we will do then is we'll create an index HTML, right? And write just hello world into it. And then we'll deploy the whole thing, but initially just with port 80, you know, just basic HTTP, and using Docker for the whole thing. So it should pull everything properly, right? Then we can confirm that the Caddy server itself is up. I think it should be something like 4 seconds, something like this. We can also check it here. It should say something like hello world right here, meaning that the web server itself is up and running. All right. So now what we can do is do a curl towards the local host, right? And we get back the hello world. Makes sense, right? So what we want to do now, though, as a second one, is curl to the HTTPS, right? And here we see, well, connection refused, right? The whole thing doesn't work on 443. Therefore, well, or HTTPS for that matter, and therefore we get a problem. So what is happening behind the scenes? As we deploy everything using Docker, we can go ahead and say Docker logs Caddy server, right? And as you can see here, Caddy itself has an automated HTTPS challenge, meaning it will check which port is being used and will try to use HTTPS first if the port is right. But as you can see here, server is listening only on HTTP ports, so no automatic HTTPS will be applied, right? So fair enough. That is what we have right now. So let's check in, and this is the behavior without HTTPS. And now let's go ahead and enable a couple of other things, especially when it comes to Vault. So what we need to do initially right now, right, is go ahead and deploy Vault. What is crucial here to know, so to say, is something that you can see right here. We have add host, right, where we add caddy-server.learn.internal with the IP address to it. This is crucial in order to make Vault understand/reach the Caddy server, right? Otherwise, the whole problem or the other thing won't work. So we're going ahead and doing now exactly that. Just set a couple of environment variables and deploy Vault. Once that is done, we can confirm that Vault is up and running. So right now it is up and running. It's just the basics of it, right? So we are working here with Vault Community Edition. We will later talk a little bit about Vault Enterprise and the pros and cons about it. So what we do now is we go ahead, export the Vault address, right? Which is this 1.10.1. Marianne, yes.
Can you make the letters a bit bigger? Is it
possible?
The
letters a bit bigger. Sure, definitely. Just give me a sec. Plus.
Perfect, thank you.
Perfect. Hope everybody can see it now a little bit better. So what we see now, or what we're going to do now, is the Vault status. And Vault should be saying something like Shamir as a seal type, right? And now what we're going to do is just log in. It is a def Vault instance, right? So therefore we just log in using root as a usage, and that's about it. Vault is up and ready for use. So what is the next thing that we want to do? Well, Vault is done, the initial setup, but now let's configure the things that we've seen before, right? So we need to configure the root CA with the name PKI, right? And then the immediate CA with PKI_int. So for this piece, just obviously we can just execute this shell script and then just let it be, but let's jump into the shell script itself before we just blatantly execute it, so that we can just see what is being done. As I mentioned before, the whole ACME thing relies on PKI. So one of the first things that we need to do, obviously, right, is to enable PKI, right? So then we tune the secrets a little bit as well for this specific name, right, which is PKI. Then we call this one with the common name root, not root, but rather learn.internal. This serves itself as a root CA, right? We write into the config the path right here of our Vault server, right? Then we create a role, right? Which allows a lot of things, right? So this can obviously be optimated, but it will serve us well enough for this particular hands-on lab. Then we go ahead and configure a couple of URLs, right? Those URLs that you can see right here is who is issuing the certificate, CRL, right, OSP, and enable templating, which is true, as this is all Vault PKI things right now. All of this can still work. And then the second one, what we will create is we enable a new one, PKI, but in this particular path, right, which is PKI_int. And we tune the secret a little bit again. Now the common name, though, is the learn.internal intermediate authority, right? The issuer name is learn intermediate. We go ahead and create a CSR for it, and we reference the root certificate from above in order to sign it, right? And we write into it. Perfect, right? And eventually we'll create a role called learn, right? Where we go ahead and say, this is the maximum of 90 days, respectively maximum TTL that we can leverage in here. All right. So now let's go ahead and just execute this script as it gives us the basic configuration piece. It will be quite a lot that will be enabled. As you can see from here, quite a bit that we have seen. And now we can list all our secrets. One of the secret engines that we should have now is the Vault PKI right here, and the PKI int underneath it that shows us, okay, we have configured now PKI 1, PKI 2, so to say. All right. First things done when it comes to configuring Vault. Now what we need to do is make it ACME, right? Make it work with ACME. So let's go ahead and start this step itself. First and foremost, let's go ahead and see whether those cluster paths are set correctly, right? And we should see one path, which is just path, and then the AI path, which should both refer to PKI int, and most importantly, refers to this particular IP address, right? This is crucial that these are the same names when it comes to for name resolution, respectively network traffic, that we have here, the same names that we have configured in the address. Otherwise, the whole thing won't fly as good. All right. And as I said before, in one of the slides, we now go ahead and tune this particular PKI int, right? Where we say this particular PKI int needs to be tuned in order for ACME to work, right? And it says, now we say link, replay nonce, and location. All of this should be enabled in order for ACME to function. Those two things are just two more things that you can set. You don't need to set, but you can set these things. So let's execute this, and we tune the secrets, which makes sense. And now we just go ahead and enable ACME, right? So we go ahead into the config, into ACME, and just say, please enable it on truth. If we wanted to, we can go ahead and also set the EAB, the external access binding. We can also configure it here if we wanted to, right? Meaning that we would need an HMAC key and a key ID in order to reference it. We could do it, especially if we have HPC Vault, meaning our cloud offering. This is set to true by default, right? Because it's an external Vault instance. Otherwise, everybody that can just prove a little bit can issue a certificate, right? Which we might not want to do. So let's go ahead and execute this. Looks similar, right? It's just the basics of it, meaning sign verbatim, and it will get the job done, as I mentioned before, but shouldn't be used most certainly here in production. All right. So now let's go ahead and deploy again the caddy server, but this time using the 443. So, whoops. Yeah, incorrect solution makes sense because I didn't start it yet. All right. So first of all, let's go ahead and remove this caddy file or the caddy data within this particular folder, as it is a stateful server, right? And restores the state. And next thing is now an important piece, I'd say. Very important indeed. What we say here is, if I go ahead and maybe zoom in a little bit more. what we can configure here, or what we are actually configuring, is we are making use of the global options within a caddy file. So a caddy file basically says, how does the caddy server actually function, right? And then here we are defining ACME CA to be our vault local address, right? And this is the directory, right? Everything starts with a get towards this specifically or this specific directory, right? In order to get the other addresses that are built from this main address, let me put it like this, right? And then here we say, what's the name of our server, right? And then just a little bit of the configuration, what we should do, what we should serve in that sense. If we wanted to include external binding, we would mention it right here, right? Where we add a couple of more things. Who is issuing it? What's the key ID? What's the HMAC value? More particularly. This is global. We can also go a little bit down and configure TLS like way more specific, but as not everybody is using caddy as a web server, just should be good enough. So let's write the caddy file, right, which is more or less our configuration file. And what we're done now, or what we're doing now, is we go ahead and create a Docker container again, right, which is called learn local, but also here is the host name, right, is correlating / the IP address, right, is correlating to what we have set initially when it comes to vault, right, where we said -add host, right. This is the host that we are adding now. So let's go ahead, start this container, which should work. And if I check now with Docker PS, right, we can see, all right, server's up and running. And now we can dig into the whole thing. What is actually happening now behind the scenes, right? All of this is done automatically. What is actually happening, or what is actually happening now? And this is quite interesting to see now. First of all, there should be way more logs than we initially had, right? And a couple of other things that we've seen here, right? So first and foremost, what we should see is something that it is listening to the HTTP port right here. Oops. It is listening to HTTP. Just give me a sec. So, serve only on HTTP port has no TLS policies, right? All right. So what we need to enable now is to go ahead and create, or what it does automatically now is go ahead and say, all right, I want to use now automatic HTTPS. Is there something that I need to obtain, right? So we are executing TLS obtain, acquiring log, right? First thing, then the log is acquired. Now we are obtaining the certificate, and how we're going to do it, we're going to use it using ACME, right? So first thing is we are waiting on the internal rate limiter. Fair enough, right? We have seen the rate limiter, and then we go ahead and have here our trying to solve the challenge, right? And what is the challenge in this particular case, right? The default behavior, it's HTTP, right? So we have an HTTP challenge that we need to solve now, respectively, that the ACME client needs to solve in order to obtain the certificate or being able to do it, right? Then we authenticate again, right? And eventually what we should see is something like successfully downloaded available certificate chains, respectively, certificate obtained successfully. That should be what we see right here. And let's check. And let's go ahead and do our curl again. So for this session itself, or for the last thing, what we will do now is go ahead and test curl. So what we need to do now, because, well, obviously this is not a real domain, right? Learn.internal, and I can't prove ownership for it, right? We need to do, when it comes to the curl, we need to mention our CA certificate, right? And we need to resolve a little bit differently, meaning this one is on port 43, but it's actually served here on our local host, right? So if we should do, or if we execute this, we should get a hello world back, which makes sense, but we can dig a little bit deeper into it if we wanted to, using the OpenSSL, which is also installed in here. And if I look into this one a little bit more differently, I can see here, oops, just give me a sec, here, that the issue itself is the immediate intermediate authority, right? Seems like what we have configured initially. And here we can see even the certificate chain, right? It's from learn.internal, which is our root one, right? And then we have eventually the intermediate one, right? All right. So there are a couple of bonuses that you can execute as well, right? Change a little bit, a couple of things to the host name that you can do, or revoke the whole certificate. We go on ahead here into root and enter here the root password, which is just root, and go ahead into the PKI and now into the certificate. We should see one certificate that is being issued, right? And this is the SAN, which is the kserver.learn.internal. As you can see here, right, it is now yeah, for almost a month is a good. What you could potentially do is revoke the certificate, start the whole thing again, you know, to see whether you get a new certificate or not. Promise you will, but that's it more or less for the hands-on lab. So you can explore this, leave it open as such, start it again if you wanted to. This is just first things. So let's jump back into the conclusion and a little bit of other things. So just stop share right here and come back to slide deck. Right. Summary, next steps and more, right? So what are good practices, best practices once we are configuring this, right? So first things what we should know once we are going ahead and talking about this whole thing, right, is that ACME only issues certificate on the active node, right? So if we have multiple vault servers running in an HA setup, only the active one is actually issuing the certificates. We should probably configure automatic tidying, right? Because at some point, we should tidy up the certificates that are old and so on and so forth, right? We can do this using the tidy ACME one. We can also add a safety buffer to also those things. That's one thing. As it is not part of the vault authentication flow, right? We should restrict the allowed rules, the allowed issuers, right? And the default policy, or eventually set this EAB policy to always required, as I mentioned before, right? As it is also not part of the entity system of Vault, this templating for policies cannot be used, right? So therefore, we need to work a little bit on the restriction parts using ACME methods. And there are a couple of other ones, as I mentioned before, meaning if we have a public-facing Vault, right, that it runs on the internet, we should always set this one to always required, right? Either setting it directly using the tuning one, or we can go ahead and use this environment variable, which is the default in HPC Vault, right? And when it comes to which challenge should I use, right? HTTP challenge shouldn't be used too much. DNS is the safest. Then we can go for the TLS one, and HTTP last. Works here quite easy though, as you could see. Therefore, we just left it as such, right? But should maybe not be used in production. So taking a summary itself, and then let's see a little bit of more steps what we can take, right? Is we have ACME as this open standard protocol itself, right? Which takes ownership, respectively, allows us to completely automate the certificate assurance and the whole lifecycle management of such, right? So we can replicate, we have the possibilities to make use of Vault plus this particular standard. It's ideal for managing a lot of services if we wanted to, right? we do not need to get to know Vault too much. If we wanted to, we can still do it, but Vault API or the authentication of Vault or something like this is not needed for this particular protocol, right? And it complements the PKI engine itself, right, that we have before it. So what's the next steps and what's more, right? So a couple of things that I want to encourage you to go ahead maybe and read upon, right? There is a section within the API documentation within the HashiCorp documents, right? Which is how do I automate the rotation using ACME, right? And there are 2 tutorials that you might want to have a look into. First is then how do I actually build a CA, a proper CA with an offline route, right? And how do I configure the CRL and the OSEP with cross-cluster revocation, right? So those are 2 more advanced things I'd say that you should have a look into or can have a look into. And last but not least, when it comes to Vault itself, all of this has been executed obviously on a community edition, right? But if you go ahead and want to introduce maybe multiple namespaces, right, for better governance or better organization of your whole environment, who should configure the intermediate, who should configure the root one, you know, maybe you have an issuing one as well in there, right? Who has ownership of what? Then you might want to think about Vault Enterprise, as well as if you're thinking about a disaster recovery process for the whole thing, right? As it is a CA, you want to check that maybe as well. If you need to increase your security on top with the introduction of an HSM, right, which I mentioned before, it's only possible with Vault Enterprise as well. And if you need to go ahead and replicate certain secrets or certificates across the globe, so to say, then also have a look maybe into Vault Enterprise and talk to us when it comes to those things. All right. This is more or less the workshop for today. We are good in timing. We have maybe time. We have maybe time here, just a couple of resources that you can check on, right? Also a couple of good things like what is a Vault PKI. We also have a white paper on PKI itself, not PKI ACME, but just PKI, that you can just have a look into. Otherwise, I would say thank you so much for it. I'll leave the Q&A a little bit open so that we can talk a little bit about the whole thing. And if you have questions, go ahead and ask them in the Q&A. Otherwise, thanks for attending and see you soon.